Okay, let's dive straight in. We're talking about a dinosaur with a really evocative name today, Aegyptosaurus.
Egypt's lizard.
Yeah.
It immediately places you somewhere, doesn't it?
Absolutely. And when as well? We're looking at what, roughly 95 million years ago?
Yeah, right in the late Cretaceous period, the Cenomanian stage
Uh,
specifically. And the where is, unsurprisingly given the name, the region we now call Africa, particularly Egypt initially.
a very different world back then.
Completely. And our understanding, well, it comes from the scientific detective work, doesn't it? Based on descriptions, findings.
Right, starting with that key specimen, the holotype.
Exactly. Specimen 1912 VI 61, found in Egypt's Baharia Formation.
And this is the work of Ernst Stromer and Richard Markgraf.
That's the team, yes. They were working there between about 1910 and 1913, give or take. And those first crucial pieces, they were sent off to Munich in 1915.
But the actual description, the naming, that came quite a bit later.
It did. 17 years later, in fact, 1932. That's when Stromer formally described Aegyptosaurus.
And interestingly, while it started in Egypt, it wasn't just Egypt, was it? Finds popped up elsewhere.
That's right. Fossils that seem to be Aegyptosaurus, or very closely related, have also been found in Niger, in the Farak Formation, and other spots across the Sahara.
So it had a pretty decent range.
It suggests so, yeah. Which is fascinating when you think about the Sahara today.
Definitely. So for you listening, our goal here is to really get a handle on what makes Egyptosaurus significant and, what its story tells us about that lost world.
It's a window into a very specific time and place.
So that name again, Egypt's lizard. Egypto for Egypt, Sauros is Greek for lizard. Simple enough.
Pretty clear naming convention there.
And that first find, the holotype, it wasn't a complete skeleton or anything, was it?
No, not at all.
No.
We're talking about three-tailed vertebrae, a piece of the shoulder blade, the scapula, and some limb bones. Fragments, really.
But enough to identify something new. It really shows that collaboration, doesn't it? Stromer the scientist, Markgraf the collector.
Yeah, that combination is often key in paleontology. Boots on the ground and expert analysis back in the lab.
What strikes me is the timing you mentioned earlier. This holotype, it arrived in Munich basically alongside another famous discovery.
Spinosaurus aegyptiacus, yes. Imagine those two sets of bones. The first clues to these incredible Egyptian giants arriving in the same place around the same time.
It's quite the image, which unfortunately leads us to a really, really sad part of the story.
The fate of those original fossils.
They were all stored in Munich, the Aegyptosaurus holotype, the Spinosaurus material, everything found before 1939.
And then World War II happened. It's, well, the gut punch for paleontology.
April 25th, 1944.
An Allied bombing raid hit Munich, and the museum housing those fossils was destroyed completely.
Gone.
Irreplaceable pieces of Earth's history, just obliterated. Decades of discovery wiped out.
So everything we know now about the original Aegyptosaurus, it's based on what? Notes, drawings.
Primarily Stromer's detailed descriptions and illustrations, yes. And then we have those other fragments found later, the ones from Egypt and Niger, which are attributed to the genus but aren't the original type specimen.
It adds such a layer of tragedy, but also highlights the fragility of this kind of evidence.
It really does. We're piecing together giants from ghosts, in a way.
So let's try and place this ghost, classification-wise. Where does Aegyptosaurus fit in the grand tree of life?
Okay, yeah, let's zoom out and back in. So Domi eukaryota, standard for complex life. Kingdom Animalia, it's an animal. Phylum Chordata has a spinal cord precursor.
Right, the basics.
Then Dinosauria, obviously. Clade Saurischia, the lizard hip dinosaurs.
Which includes the sauropods.
Exactly. So next is Sauropodomorpha, the group containing the long-necked herbivores. Then Sauropoda itself, the classic four-legged giants.
Getting more specific now.
Yep. Macronaria is next sauropods, often with large nasal openings high on the skull. And then the really key group here, Titanosauria.
Titanosauria, that's a big deal in the Cretaceous, right? Especially in the southern continents.
Huge deal, a very diverse and successful group of sauropods, many reaching enormous sizes. They were really dominant in Gondwana.
And Aegyptosaurus is one of them.
Right, so genus Aegyptosaurus. And the type species, based on that lost holotype, is Aegyptosaurus bahariensis, named for the Baharia oasis where it was found.
So being a titanosaur gives us some idea of its potential size, even without the original bones. We have to rely on estimates.
We do. It's all comparative anatomy. Gregory S. Paul, back in 2010, looked at the available data, compared it with relatives like Paralidoton.
Another giant from the same area.
Exactly. And his estimate put Aegyptosaurus at around 15 meters long.
Okay, 15 meter. That's about 49 feet.
Yeah. And weight-wise, maybe around 7 tons, so 7.7 short tons.
So a big animal. Maybe not the absolute biggest titanosaur, but definitely
Oh,
large.
definitely a substantial creature. Imagine something the length of maybe 3 large cars, weighing as much as an elephant or two,
Yeah.
roaming that ancient landscape.
Which you described as very different from today. What was that Baharia Formation environment actually like back then in the Cenomanian?
Well, evidence points towards a mangrove ecosystem.
Mangroves. In what's now the Sahara.
Yep. Situated along the southern coast of the Tethys Sea, this huge ancient ocean that separated Africa from Eurasia. Think coastal, humid, maybe swampy areas.
And the plants, not desert scrub, presumably.
No, we find fossils of things like Weichselia reticulata. That's a type of seed fern. So lush vegetation, at least in patches, supporting these giant herbivores.
It's hard to even picture it, a green Sahara edge bordering an ancient sea.
Drastically different. It shows just how dynamic our planet is over geological time.
And Aegyptosaurus wasn't living there alone, was it? It had some pretty formidable neighbors.
Oh, absolutely not alone. The Baharia Formation was, well, a bit of a land of giants.
Like who?
You had massive predators. There was Tamaryraptor, a big carnivore, initially thought to be Carcharodontosaurus, but now seen as distinct.
Okay, a giant meat eater.
A very large one. And then, of course, the star predator of the region, Spinosaurus.
Right, the semi-aquatic giant with the sail.
That's the one, possibly the largest theropod ever. And if that wasn't enough,
And there were other sauropods too.
yep, another huge titanosaur, Paralidoton, shared the same habitat at the same time.
Wow. So Aegyptosaurus is grazing in these mangroves, and it's got Spinosaurus in the water, Tamaraptor on land, and another giant sauropod potentially competing for food.
It must have been an incredible and probably quite dangerous ecosystem to live in. Size would definitely have been an advantage.
No kidding. You mentioned some other finds potentially related after the original discovery and loss.
Yes, there was a mention by de la Parent in 1960. He described some tail vertebrae, caudal vertebrae, from a different rock layer in Egypt, the continental intercalaire.
And he thought they were Aegyptosaurus.
He attributed them to Aegyptosaurus baharigensis, yes, which, if correct, might suggest the species, or something very like it, was around for a while or had a slightly broader range within North Africa than just Baharia, but it's still fragmentary evidence.
Right, always piecing things together. Okay, so let's sort of recap what we've covered about Egypt's lizard.
Sure.
We've got the name origin, the initial discovery by Stromer and Markgraf in Egypt, sent to Munich alongside Spinosaurus.
Then the tragic loss of those crucial original fossils in World War II, a major blow.
Which means our understanding relies on Stromer's work and later, more fragmentary finds from Egypt and Niger.
We placed it firmly within the Titanosaura, a major group of Cretaceous sauropods.
And we got a sense of its size, estimated around 15 meters long, 7 tons. A big animal.
Definitely. Living in that fascinating ancient mangrove environment on the edge of the Tethys Sea.
Sharing its world with giant predators like Tamaryraptor and Spinosaurus, and another huge sauropod, Paralidoton.
It paints a picture of a truly remarkable prehistoric ecosystem.
It really does. And it's amazing what can be reconstructed from, essentially, scattered puzzle pieces, especially after losing the box lid, so to speak.
It's a testament to the methods and, well, the persistence of paleontologists.
Which leads us perfectly into a final thought for you, the listener. Given that the absolute key piece of evidence, the holotype, was destroyed, and we're working with these other fragments and historical descriptions, how much of our picture of Aegyptosaurus is still, well, provisional?
Based on solid inference and comparison, yes, but still built on incomplete data.
And what might change? What discovery, maybe lying out there still under the Saharan sand, could completely reshape how we see this Egypt's lizard? Could we find a more complete skeleton one day?
It's always possible. Unlikely, perhaps, but possible.
It makes you think about just how fragile our knowledge of the past is and how every new fossil, however small, can potentially rewrite a chapter. The adventure of discovery really is ongoing, isn't it?
Absolutely. There's always more to learn.